100 aircraft, one airline, one decade, and an aircraft that currently rolls out of its factory at the pace of roughly one per year. That's the gap between where Russia's Tu-214 program stands today and where S-7 Airlines needs it to be. And here's what makes this story genuinely fascinating. Russia isn't just trying to build more of an existing aircraft. It's trying to reinvent one, completely, from the cockpit to the supply chain, from the assembly line to the certification records. While the clock is already ticking, can they actually pull this off? Or is this the kind of bold industrial vision that looks compelling on paper and unravels the moment it meets reality? Stick around, because the answer is more complicated and more interesting than either side wants to admit. If deep aviation analysis like this is what you're here for, subscribe right now and hit that notification bell. Let's get into it. Let's start with what's actually being proposed here. Because the headline number, 100 aircraft, doesn't tell you the full story. S-7 Airlines, one of Russia's largest and most commercially sophisticated carriers, is in advanced exploratory discussions to acquire up to 100 modernized Tupolev Tu-214 aircraft. The discussions have moved beyond the conceptual stage. Technical requirements are being assessed. Production timelines are being scrutinized. Delivery schedules are being stress-tested against current industrial capability. If the program proceeds as intended, deliveries could begin as early as 2029. That's 3 years away. Now, why does S-7 matter in this story? Because S-7 isn't a flag carrier operating on political mandate. It's a commercially driven airline that competes for passengers, manages costs rigorously, and evaluates aircraft on economic merit. If S-7 is engaging seriously with the Tu-214 program, it signals something important, that the modernized aircraft might actually make commercial sense, not just political sense. But here's what makes this deal genuinely ambitious, bordering on audacious. The Tu-214 being discussed for S-7 is not the Tu-214 that exists today. It's not a continuation of the current production model. What's being proposed is a deep, comprehensive modernization, a transformation of the aircraft's fundamental operating economics, its cockpit architecture, its maintenance profile, and its production infrastructure. In other words, Russia isn't just planning to build more of an existing aircraft. It's planning to build a substantially different aircraft at 10 times the current production rate within a timeline that leaves almost no margin for delay. And this is where the real story begins. Because the gap between the ambition and the current reality is enormous. Understanding that gap, honestly, without either dismissing the program or blindly cheerleading it, is what this breakdown is actually about. Before we can talk about what the modernized Tu-214 needs to become, we need to understand what it currently is. The Tu-214 is a Soviet lineage narrow-body jet. Twin engines. 210 passengers in a typical configuration. Range that makes it genuinely capable on medium-haul routes. It's a solid, proven airframe with real operational history behind it. But proven and competitive are not the same thing. And in modern commercial aviation, the gap between those two words costs airlines millions of dollars every year. Here's the core problem. The Tu-214 in its current form requires a 3-person flight crew. Pilot, co-pilot, flight engineer. That third person, the flight engineer, was a standard crew member on aircraft designed in the Soviet era, responsible for monitoring and managing aircraft systems that modern automation handles automatically. The rest of the world moved to two-pilot operations decades ago. Every Airbus, every Boeing, every modern narrow-body flying today operates with 2 pilots. Not because aviation got reckless about safety, but because automation got good enough to handle what the flight engineer previously managed, more reliably and more consistently than a human could. So why does the third crew member matter so much economically? Flight crew costs are one of the largest operating expenses for any airline. Pilots are expensive to train, expensive to certify, and expensive to roster. Adding a third qualified crew member to every flight doesn't just increase direct salary costs. It multiplies scheduling complexity, training requirements, and certification overhead across the entire operation. For a carrier like S-7 operating hundreds of flights per day, that cost differential is not marginal. It's structural. It's built into every single flight, every single day, for the entire service life of the fleet. This is why the two-pilot cockpit transition isn't optional. It's the price of admission for commercial viability. But transitioning from three-pilot to two-pilot operations isn't as simple as removing a seat. It's one of the most complex engineering and certification challenges the entire modernization program faces. Think about what the flight engineer actually did on the original Tu-214. Monitoring engine parameters, managing fuel systems, overseeing hydraulics, pneumatics, electrical systems, watching for abnormalities across dozens of instruments and intervening when something needed attention. It was a full-time cognitive workload, necessary precisely because the aircraft systems weren't automated enough to manage themselves. Now remove that person. Everything they monitored still needs to be monitored. Everything they managed still needs to be managed. But now it has to happen without them. That means the aircraft's entire systems architecture has to be redesigned around automation. Advanced flight management systems must take over the monitoring and management tasks the engineer previously handled. Warning and alerting systems must be sophisticated enough to flag abnormalities that would previously have been caught by a dedicated pair of human eyes. The cockpit interface, every display, every control, every workflow, must be redesigned so that two pilots can manage the full operational picture without cognitive overload. And here's where the complexity compounds. This isn't just an engineering challenge. It's a certification challenge. Every change to cockpit architecture, every new automated system, every modified pilot workflow must be validated through a rigorous process: ground testing, flight trials, regulatory review. Aviation authorities don't take shortcuts on cockpit redesign, and they shouldn't. The consequences of getting it wrong are catastrophic and irreversible. Certification of major avionics changes is measured in years, not months. And any unexpected technical issue discovered during testing, a software anomaly, an integration problem between systems, an edge case in the automation logic, can extend that timeline significantly. This is one of the program's highest risk elements, and it hasn't even begun in earnest yet. Beyond the cockpit, the modernization scope extends further still. Airlines like S7 don't just buy aircraft, they buy economics. They need predictable maintenance costs, longer intervals between scheduled maintenance events, high dispatch reliability that keeps aircraft flying rather than sitting in hangars. These requirements drive engineering improvements across multiple systems, engines, onboard electronics, structural components, that each carry their own development and certification burden. The modernization isn't one project. It's dozens of parallel projects that all have to converge on the same timeline. And now add the production challenge, because this is where the numbers get genuinely alarming. Let's be very direct about this. The Kazan Aviation plant, which manufactures the Tu-214, currently produces approximately 1 aircraft per year. 1. The S7 deal requires 10 per year. That's not an incremental improvement. That's not optimizing an existing process or adding a second shift. A tenfold increase in production rate represents a fundamental transformation of industrial capability, the kind of transformation that takes years to plan, years to execute, and years to stabilize at the target output. So what does going from 1 to 10 aircraft per year actually require? Start with the factory itself. The physical production lines, the jigs, fixtures, tooling, and assembly stations need to be expanded dramatically. New buildings may need to be constructed. Existing facilities need to be reconfigured. The flow of work through the plant needs to be redesigned for higher throughput without creating bottlenecks that constrain the entire line. Then there's the workforce. Skilled aerospace manufacturing workers aren't hired off the street. They're trained over months and years. Sheet metal workers, composite technicians, avionics installers, systems integration specialists, quality control engineers. Every additional aircraft per year requires more of all of them. And training capacity itself becomes a bottleneck. You can't accelerate skill development beyond a certain pace without compromising the quality of the output. But here's where it gets even more complicated. The factory doesn't manufacture most of what goes into an aircraft. It assembles components that come from a network of suppliers. Engines, avionics boxes, structural subassemblies, landing gear, hydraulic systems. Each of these comes from a separate facility with its own production constraints, its own workforce limitations, its own quality standards. To produce 10 Tu-214s per year, every supplier in that network needs to be producing at 10 times their current rate, simultaneously in synchronization without quality failures that force rework or reject components. Supply chains are where aviation programs live or die. And right now, the Tu-214 supply chain is not configured for this. Add to this the import substitution pressure. Many components that were previously sourced internationally now need to be produced domestically. That means establishing new production capabilities from scratch for some components, finding or creating suppliers, qualifying them to aviation standards, integrating them into the supply network. Each of these is a multi-year process on its own. And remember, all of this has to happen at the same time the aircraft is being redesigned. Here's a concept that aviation insiders understand well, but rarely gets explained clearly to general audiences. In an ideal world, aircraft programs follow a sequential logic. You design the aircraft completely. You build prototypes and test them. You certify the design. Then you begin production. Each stage is complete before the next begins. In the real world, especially under commercial and political time pressure, programs almost never work that way. To meet a 2029 delivery target for the modernized Tu-214, production preparation almost certainly needs to begin before the redesign is fully finalized and certified. Factory expansion can't wait for the last avionics system to be certified. Supplier qualification can't wait for the final weight and balance calculation. Workforce training can't wait for the completed flight manual. This parallel approach, developing and producing simultaneously, is a calculated risk management strategy. It compresses the overall timeline by overlapping phases that would otherwise be sequential. But it carries real danger. If a design change is required late in the certification process, and with a redesign of the scope, late changes are not unusual, it can cascade backwards through production preparation that's already underway. Tooling that was built to the old specification needs to be modified. Workers trained on the old configuration need retraining. Suppliers already producing components to previous drawings need to be redirected. Every late design change in a parallel development program multiplies its cost and schedule impact by the number of downstream processes that were already running against the old baseline. This is how programs that look achievable on paper turn into programs that slip by years in practice. The 2029 target is not impossible. But it requires everything to go roughly right: the certification process, the supplier qualification, the factory expansion, the workforce buildup, essentially simultaneously, with minimal major surprises in any of them. In aviation, minimal major surprises is not a planning assumption. It's a hope. Stepping back from the engineering and production challenges, it's worth asking a more fundamental question. Why is this deal being pursued at all? And why is S7 the airline at the center of it? The geopolitical context is impossible to separate from the commercial one. Russia's access to Western aircraft, Boeing and Airbus, has been severely constrained by sanctions. Airlines that built their fleets around these aircraft are now operating aging jets past their intended retirement dates, unable to source new deliveries or, in some cases, replacement parts. The long-term fleet renewal problem for Russian carriers is not a future concern. It's an immediate operational reality. For S7, which had historically operated a modern, predominantly Western fleet, this creates genuine strategic pressure. Without access to new Airbus or Boeing aircraft, the airline needs an alternative. And the Tu-214 modernized, domestically produced, immune to foreign export controls, is the most credible narrow-body option Russia currently has on the horizon. But S7 isn't going to accept an inferior aircraft simply because it's available. This is a commercially driven airline with real competitive pressures. If the modernized Tu-214 can't match the operating economics of the aircraft it replaces, if its fuel burn is significantly worse, if its maintenance costs are higher, if its dispatch reliability falls short, S7 will feel that in its profit and loss statement every quarter. Which is exactly why the two-pilot cockpit matters so much. Why the maintenance interval improvements matter. Why every engineering decision in this modernization has to be anchored in real operating economics, not just technical feasibility. S7's engagement in the program, its willingness to be involved in defining technical requirements, is actually a quality filter. An airline with S7 standards won't accept a modernization that's cosmetic. It will push for real performance improvements, real cost competitiveness, real reliability guarantees. That pressure, paradoxically, makes the program more credible. But it also makes the engineering challenge harder. And beyond S7's commercial interests, there's a broader national dimension to this story that's just as important. The Tu-214 for S7 isn't just a commercial aircraft deal. It's a test case. If Russia can successfully modernize the Tu-214, complete the redesign, certify the two-pilot cockpit, ramp production to 10 aircraft per year, and deliver reliably to a commercially sophisticated airline, it demonstrates something far more significant than one successful program. It demonstrates that Russia's aviation industry can execute complex, high-volume aircraft production at modern commercial standards. And that capability, or the lack of it, will define the entire trajectory of Russian civil aviation for the next generation. Think about what's at stake in the supply chain dimension alone. Building the network of domestic suppliers capable of supporting 10 Tu-214s per year doesn't just serve this program. It builds industrial capability, manufacturing processes, quality systems, technical expertise, logistical infrastructure that can be applied to other programs. The MC-21, future variants, potentially next-generation designs that don't yet exist. Industrial capability compounds, a supplier that learns to produce aircraft-grade hydraulic components for the Tu-214 can produce them for other aircraft. A factory that builds composite structural subassemblies at volume for one program has the process knowledge to do it for the next one. Conversely, if this program stumbles, if the production ramp fails, if certification delays push deliveries years past 2029, if quality problems emerge in early service, the damage extends beyond a single aircraft type. It undermines confidence in the entire domestic aviation industrial base. It makes future programs harder to fund, harder to sell to airlines, and harder to staff with experienced engineers who see a credible career ahead of them. The Tu-214 modernization program carries institutional stakes that go well beyond S7's fleet renewal. Let's be honest here, because this story deserves honesty more than it deserves optimism or pessimism. The 2029 target for first deliveries is aggressive. Very aggressive. The redesign, particularly the two-pilot cockpit, hasn't been fully completed. Certification of major avionics systems typically takes 2 to 3 years minimum under favorable conditions, and that clock doesn't start until the design is sufficiently mature to begin formal testing. If design work isn't fully underway now, 2029 for certified deliveries is extremely tight. The production ramp is a multi-year project that needs to begin essentially immediately. Factory expansion, supplier qualification, workforce development, these aren't parallel tracks that can be accelerated indefinitely by throwing more money at them. They're constrained by physical reality. Buildings take time to construct. Workers take time to train. Suppliers take time to qualify. And import substitution adds another layer of uncertainty to every component in the supply chain. So is 2029 achievable? Possibly. Under the best-case scenario, where design work is further advanced than publicly acknowledged, where certification proceeds without major unexpected findings, where factory expansion begins immediately and proceeds without significant delays, where suppliers are qualified on schedule, 2029 for initial deliveries is within the range of possibility. But within the range of possibility and planned with confidence are very different things. The more realistic scenario, based on the current gap between production capability and stated targets, probably involves initial deliveries somewhere in the 2030 to 2031 timeframe, with the full production rate of 10 aircraft per year not achieved until several years after that. That's not failure. That's the normal trajectory of complex aircraft programs operating under genuine industrial constraints. But it does matter enormously for S7's fleet planning, and for the broader narrative about Russia's aviation industry, because timelines that slip publicly undermine institutional confidence in ways that are slow to rebuild. In aviation, there's a phrase that experienced program managers use when timelines get ambitious and stakeholder expectations outpace industrial reality. Hope is not a plan. The Tu-214 modernization program for S-7 Airlines has genuine ambition behind it. The strategic logic is sound. Russia needs domestic narrowbody aircraft, S-7 needs fleet renewal options, and the Tu-214 is the most credible platform available. The modernization vision, two-pilot operations, modern economics, improved reliability, is exactly the right direction. But ambition and vision don't move metal. What moves metal is a completed cockpit redesign, certified by aviation authorities after years of rigorous testing. What moves metal is a factory running 10 times its current production rate, fed by a fully qualified domestic supply chain, delivering components on time and to specification. What moves metal is a workforce, engineers, technicians, inspectors, managers, large enough, skilled enough, and experienced enough to sustain that output without compromising quality. None of those things exist yet at the scale required. Building them is the real challenge of this program. Not the announcement, not the exploratory discussions, not the ambitious delivery targets. The actual, physical, industrial work of creating a production capability that doesn't currently exist. Can Russia do it? The honest answer is we don't know yet. The tools are available. The strategic motivation is clear. The engineering foundation is real. But execution at this scale, on this timeline, with these constraints, that's where programs either prove themselves or reveal their limits. The Tu-214 modernization isn't just about building airplanes for S-7. It's about proving that Russia's aviation industry can transform under pressure. Not just survive. Not just produce in small numbers for captive domestic customers, but genuinely transform and deliver modern aircraft at commercial production rates to an airline that demands real performance and won't accept excuses. Whether that proof materializes by 2029 or 2031 or later still, that's the question the entire Russian aviation industry is watching. And frankly, so should the rest of us. Where do you stand on this? Do you think the Tu-214 modernization can hit its targets? Or is the gap between ambition and reality too wide to close on this timeline? Tell me in the comments. Genuinely want to hear your take. And if this level of honest, in-depth analysis is what you want more of, subscribe, share this with someone who follows aviation closely, and hit the like button. It genuinely helps. See you in the next one.